Wondering, there's already been a preliminary decision about this. Why are you taking public comment? And why are we meeting if you've already decided on this?
My name's Andy Kugler with the NRC. We haven't made any decision. That's the bottom line. This is a draft environmental impact statement because we have not yet received comment on it. So the way the process works is we prepare the draft environmental impact statement. We evaluate all of the impacts with the information that we have. We then make it available for public comment, and we take those comments and we determine what changes we need to make to the document based on those comments. So nothing is final yet. No decision has been made. And this is part of the process to get to that final environmental impact statement, which will then be part of what the Commission will use to make its decision whether or not to issue the licenses.
My name is Ann Craig, and this is probably a really dumb question because I want to ask you back to the beginning. Does Duke feels it needs to produce more electricity because why? Because this is a growing area, because people are using more power. What do they need this whole thing for?
Hi, my name is Dan Masadi, and I was in charge of doing the need for power analysis, which is Chapter 8 of the Environmental Impact Statement. If you want to have some rousing reading tonight to help put you to sleep, that would be the place to start. The answers comes in many forms. How many of you have got something like this on you right now? There are several things that are happening that make it really a dynamic world for figuring out how much power is actually needed. And the analyses that were performed by the North Carolina and South Carolina Public Utility Commissions are pretty uniform in noting that not only is the population growing in the areas, it's not growing as fast as it was 8 or 9 years ago, but populations in general in the service area are not only is that growing, but the individual consumption of everybody in the area is also growing. I leave my cell phone plugged in when I'm at home. I've got a computer that's running, and I'm not even in my house. I've got a Wi-Fi connection that's sitting there blinking little lights and keeping everything up and going. And I'm pretty sure everybody else around here is kind of guilty of the same sorts of things to some extent. I'm sure you don't have a refrigerator that's running and you're not using anything in it. I mean, there are many different ways that we have power that's being used without us being around, and it's just a matter of our lives. And it's these sorts of things that's causing the, according to the two public utility commissions, that's causing the need for power to grow in the area. It's being offset to some extent by people being a little bit smarter, like the people that were yelling no at me just a minute ago, saying that they don't do these things, because we're changing our behaviors and we're learning how to be a little bit more efficient. We're changing our light bulbs and these sorts of things. But that's not enough. It's not enough to completely offset the amount of growth that is happening in just the basic population itself. So it's a combination of things, population and use individually, these sorts of things, but it's not completely offset. Did that help?
That helps. Thank you.
Hi, my name is John Buscarino. I have a specific question regarding one of the slides you threw up there, the water demands on the Broad River. The statistic that under normal operating conditions it would use 78 cubic feet per second, which was cited as 5% of the mean annual flow. But the number that was thrown up before was the low ball number of 483 cubic feet per second, which I imagine the answer to this question has something to do with the difference between mean annual flow and whatever 483 cubic feet per second that statistic was, but my math says that that's closer to 15%. So if someone could just clarify the water demands on the Broad River, that'd be good.
Yeah, thanks. My name's Lance Vail, and I'm at the Pacific Northwest National Laboratory, and I did the water use assessment. The number that is the mean annual flow that's estimated for the Lee site is about 1890 CFS. So that 483 number is a sort of regulatory low flow criteria set by FERC at that location of the requirements to be discharged at that location. So yeah, you are basing it on a different number, and I would expect it would probably be around 15% in those low flow conditions.
Hello, my name is Daniel Schmidt. I'm just curious, most of what we've heard so far as about normal operating conditions. I'm curious if how much of this considers emergency situations, you know, unexpected. You know, there are things that do go wrong. So I'm just curious, it's a two-part question, how much of this has been addressed, and then also what is the situation with waste production from this plant?
Okay, I'll take the first part of the question and turn it over for the second part of the question. When we go into the water numbers that we're talking about are dominated by the values of water that are needed to produce electricity. Those numbers are far in excess of numbers that are needed when you go into like an emergency shutdown situation. So in our assessment, we assume that these plants are operating continuously at 100% of their capacity, so that makes our assessment bounding. The flows would actually, the water demands would actually be less. And I should also point out that in those emergency conditions, these water sources that we've talked about are not required. None of these provide a safety function from any of the ponds or the Broad River.
Waste production?
Well, my name is Donald Paul Rhodes of the NRC. Radioactive waste is regulated by the NRC. They have to, Duke would have to, under the license, manage and control it to ensure protection of the public per our regulations. Which mentioned before was the 100 millirem to the public, members of the public is one limit. The other one is the 25 millirem under the Environmental Protection Agency regulations that we incorporated. They would have to manage that waste on site, and for low-level waste, they can contract with the disposal site to ship it to that site for ultimate disposal. High-level waste would have to be managed at the site until the Department of Energy could take control of it and ultimately dispose of high-level waste.
I have a question about, you have ponds, B and C that provide water if there's a drought and the river is low. How long can ponds B and C provide water for in a drought? And you seem to say that water wasn't necessary in an emergency. If there was an emergency and the wells needed to be cooled, what would cool them if you didn't use water?
My name's Brian Hughes. I'm the lead safety review for the LEAD project. Part of the design of the AP1000 is in the event that there is an emergency, it is gravity and natural evaporation or natural circulation inside and outside the building that would remove the heat. Think of a canteen, the old canteens that had the cloth.
Some great questions. We'll take it maybe another 4 minutes or so, and then we'll move into the comment period. Make sure everybody gets a chance.
Yeah, hi, my name is Ole Sorensen, and I'm an outraged citizen. And I had a question regarding the electric usage. I would like to know if you considered an alternative calculation for the so-called increased need for electricity. Did you look at someone else's calculations other than the utility commissions? Is it possible that someone has a different view on that? I'd like to know. If we need more power.
North Carolina's Public Utility Commission, South Carolina Public Utility Commission, the National Electric Reliability Council or Commission. We looked at a number of independent outside groups to look at that.
Who?
You just named them.
I just named them, sir.
Those are not independent.
Okay, well, those are the ones that the NRC used.
So, Philip Bassessi, professional engineer. I want to ask you if you have considered alternatives, electrical demand control. It's very difficult looking at the rate structure to figure if an owner should do demand control or not. But if demand control were properly applied, that would reduce the need for more plants. Second, distributed generation. Why not give an incentive for companies to have on-site electrical generation rather than having to buy from afar? I think local's better.
Yes, we do look at energy alternatives. It's part of Chapter 9, Section 9.2.
My name is Susan Corbett. I'm the chair of the South Carolina Sierra Club. I want to go back to the water issue real quickly. I have two things I want to find out here. You have to have water to make this electricity, and I see that if the Broad River gets below its minimum flow, you're going to have to draw from ponds B and C. And we all have concerns about drought in the South. We've had severe droughts in the last few years, and we're worried about Broad River. How long can you make electricity just from ponds B and C before you have to shut down? And the other question I have is about the spent fuel pool, where the spent fuel goes. I know that the reactor core is cooled by the water on top, but what is your source of water cooling in the spent fuel, and how many backup generators will this plant have in case the grid goes down?